Okay, so the class access specifiers diagram, public, and if the class has public functions or data, can they be accessible by private and public functions that live in the class? So this is public access specifier, and those are the functions, and we don't have a private function, but if we did, could they see each other? And the answer is yes. Okay, what about users? Other code like main.cpp or another object or other objects. Can they see public functions or data? And we know, and we can just prove it briefly here in main. If we go to main and bank account dot, so notice we can see anything that's public, so the answer to that one should be yes. And now what if they fall under the private specifier within the class itself? And we should know that that is true also, that is yes. These functions can see balance, and this is an example right here, right? So balance that belongs to bank account is here, and this is this one right there. So the answer is yes. Okay, what about private functions or data that are in the class? Can they be seen by users of the class, like main or other objects? And we know that this should not be the case. So if we go here and we forcefully try to access balance, we will not be able to compile our program. So it's inaccessible. So the answer there is no. Okay, so please make sure that you understand that, because I'm sure you'll see it again in a quiz. Okay, so so now we jump back to what we will cover this week. And briefly, we initialize a private data member to 0 in this bank account class. The reality is that bank accounts usually don't start off with balance of 0 unless somebody's opening a new account, right? But most of the time they have a balance. So we need to find a way to have users of our class to give us a begin balance. And those users can be a main or it can be another object, okay? So we'll go the easy way, and we talk about a special function that's called a constructor. So what is a constructor? So construct, right? So it initializes, it helps us initialize private data by using parameters with values that come into our class via the constructor. What is the syntax of the constructor? So it is a special function. It has the name of the class, and then we can have 0 or more. Hold on, I gotta tell my son to keep it down. Hold on. Okay, so as I was saying, the constructor is a special function that has the name of the class itself. It can have 0 or more parameters, and then we can, with those incoming parameters, we can do various things. Mostly we want to initialize private data. Okay, so how would that work? Or do we even need to create constructors? Like, we know our class so far like this works, and we didn't have to create a constructor. However, the reality is that behind the scenes, C++ created a constructor that looks like that. And it does that to give us the ability to create an instance of our user-defined type bank account. So this one is called the synthesized default constructor. C++ will generate this one for us if we do not have any constructors. If we have one constructor in our class, then C++ will not generate the default constructor. Why? Because it will not know if we need it or not. So then it leaves it up to us whether to add it or not. And what does that mean, right? So let's, for right now, comment that code out. And then let's tackle for now the issue about generating a value other than, or initializing this to a value other than 0. So we can say, okay, we'll use a constructor, but with one int parameter, and then we'll use this special syntax, which is an initializer list, so colon, and then balance. Which balance? This balance right here. And then open parentheses, close parentheses, B, and then open close curly brace. Okay, so what does this mean? So now this means that anytime anyone wants to use our class, they have to provide a balance for us. So they have to say like bank account amount with some balance. What does this mean? Well, we can look at the code over here and notice now this one has a warning for us. It's like no, or an error. No default constructor exists for class bank account. Okay, so what does that mean? And what is a default constructor? Okay, so let me do the opposite now. Let me comment this one out and remove the comment from line 5 and then go back to main, and notice now the Visual Studio Code IntelliSense is happy with me. So we can conclude that, oh, this is the default constructor. And we know because when I removed it on purpose, it told me that there was no default constructor to generate the class with. And our code will not compile. With that error, it won't compile. Okay, so we have the default constructor. But what if we want somebody to color a class with, like, say, a begin balance of 100, right? That's a parameter value. Notice right now, I don't have the ability to do this, but I can enable it by adding this constructor with an integer b for balance. And if I go back to main, notice now, it lets me. And will it let me do one without an initial balance? Yes. So we can conclude now that when this statement's executed, bank account, this statement's executed, which does nothing, but it works as the default constructor. And that's okay if it doesn't do anything. We are saying if nobody gives me a balance, then I'm initializing balance to 0. So I'm just going to assume that you're okay working with a begin balance of 0, okay? If somebody sends in a balance of 100, our code will still work. This statement executes. The runtime compiler scans our code and it's like, oh, I'm going to use this constructor. So B is 100. So I want balance to get the value of B, which overrides the value of 0 that balance had. So remember, when the class is created, the first piece of code that's read is this one. So balance is 0 for milliseconds. As soon as this statement executes, then balance's value is 100. And we can validate that. So we go back to main and let's see here. So CMake, SRC, examples, 6, and we go here. We go ahead and run our program. Okay, so notice now right here, balance is 100. We deposit 50. It's 150. Withdraw 10. Now it's 140. Yeah, you can set up you can set constructors for your class. That's what the string and the vector do. That's why you can initialize them with all different kinds of values. So any questions here? Again, this lecture and the next one, the first 4 lectures for classes, they're like very important because that's the foundation for the rest of the semester. So you have to make sure you understand. If not, please ask questions. Okay, so far, no questions. Okay, what if we run the old code? If we just say, okay, so let's run bank account without a parameter value, what happens? So let's run it. So balance of 0, we deposit 50, value of 50, withdraw 10, and balance of 40. So now our code with constructors is set up to work as we see fit, depending on how we want to structure our code, right, or what our application calls for. So it gives us a lot of flexibility. And now we got around the issue of having a balance of 0 for all bank accounts. It is very important to understand that if you create one constructor, this will not be generated by C++. And if I try to run this code, it won't. So I'm like, well, I don't care about that red underscore. I'm going to try to run it. Then we will get this nasty error. And let me... No matching function for call to bank account with no parameters. Meaning there's no default constructor, okay? But what if I'm like, okay, so let me remove this one for now. Will my code work? Let's see. So run in terminal. The code works. Okay. So again, that should drill home the point that the only time the synthesized default constructor is generated is when we don't include any constructors in our class. Once we include one, then C++ leaves us to be, because it's like, okay, you know what you're doing, and it will not generate the default constructor. Notice right there, no default constructor exists for class bank account. In that case, we have to take ownership and create the default constructor. We go back here and notice now we should be able to run our program. So please make sure you understand this, because this can save a lot of time for you in the future, right? So our code works. Any questions? Okay, what about our test cases? What happened to them? Do you all think our test cases still work? Yes or no? Yeah, so we have 2 yeses and 1 no. Okay, so before I go and show the test cases, this is how we were creating bank account instances for our test case. we've added some code. I mean, it's only 2 lines of code, but I mean, if main works, like main works, and this is how we were creating bank account objects for the test cases, then the answer should be, well, the test cases should still work. And that's one of the big values of test cases. And that's when compared to testing your code like I am here in main. But I wasn't really testing it. I was just showing you for demo purposes to show you how the constructors work. And we have a bank of test cases already that we can use to, however minor, test 2 new line code statements in our program, right? So we go to examples and module, and notice no red marks. So that should be a good sign, but we always want to try to run them. So let's run them and let's see if our test cases are still working. And not only working, but passing. So working meaning like can they run, and then passing meaning did our code change break anything. So we had 2 yes and 3 no's. So the answer should be yes. And linking. Okay, so green always means good. Up arrow, space, dashes, enter. And notice our test cases still work. Okay, which is good, you know, so that gives us confidence in test cases, right? So we can add code and then run our test cases again to see if we broke anything. Okay, how do we test these changes though? How can we test them? Well, we can start with this constructor. We can, because this is the one that provides the change that we wanted, right, to initialize this value. This one was already there. We just didn't visually see it. C++ added that constructor for us. So we go to test and we're like, okay, so if I can test a new bank account object with a 0 balance, and maybe I should create a test case to test new bank account with given begin balance. And then we can say, okay, bank account with value of 100. We can create the assertion with the require statement, and we can say account dot get balance equal 100. And remember, all the test cases need a different string parameter. If I use the same this one over here, then none of my test cases will run, and the the catch2 test framework won't really tell you, well, you need to use a different name. So just remember this, don't use the same name, okay? Well, let's run this. Run terminal. Also, while this is running, let me come back to main here, and then I'm gonna hold that thought for now. Sorry. Okay, so do y'all think this test case should pass? I'm talking about this one, this new one we added. Will it pass or not? Yes, it should pass. Like, if we are saying start with 100, then the begin balance should be 100. We've added the code for that. Where? Right here, like the value of B, whatever that is, assign it to the private balance, this one. Okay. So if we scroll down, we are green. Up arrow space dash S, enter. Okay, test new bank account with given begin balance 100, which is good, right? So that should right away, like if you were still like kind of on the fence about test cases, then as we modify the code, then and you see that our test cases keep on passing, then they're guiding us, right? And they will like smack our hand if something's wrong. Right away we'll have failures and we'll be like, oh, what happened? What did I mess up? Then we can change it right now, as opposed to when it goes to the test team or when it goes out into the customer's hands, right? So we always want to hopefully catch issues right now. When we write hundreds of test cases, so questions, right? So when we write hundreds of test cases in a test bank, how do we prevent accidentally writing 2 test cases with the same string name? IntelliSense will not tell you. So usually in a production environment, they might name them. They might number them. Like regardless, they might go like 1, 2, and then some name, right? Especially if they were using, at least that's what I would do. That's what I would tell my team. Like start with the number and go sequentially. That way we don't have to worry about someone using the same name. Right? Okay, so you said if you are doing multiple assertions in the same test case, you need instances with different names. I said that? So over here, no, I didn't say that, right? So here we have one instance, and we have one assertion here, and then we have another assertion over here. And notice we're just using one object. So instances with different names. I mean, there will be cases like that, but for what we're doing, one instance will be enough for us. Okay, so how about we test the bank account deposit, but with a given begin balance. So we are like, okay, so let's create another test case. Okay, so we go, okay, so bank account, start with a balance, right? So now, since I have a balance, I do not have to deposit. Well, actually, I do not need to deposit an initial value, right? I can just assume that I'm like, okay, so there's some stuff in there, and I just want to, I guess what I was saying, we don't start at 0. Okay, so deposit 50. So now our assertion should be account.getBalance should be equal to 100 plus 50 or 150. And then we can run this. If your intent is to get into the field as a developer, then learning how to use the test cases to your advantage will be a big plus. Like the experience with test cases will be a big plus, especially if others who come to ACC don't get exposed to test cases, right? Maybe they just get exposed to the C++ language. But going with test cases will make you a better developer, like in the long run. Okay, so we scroll down, not there, here, scroll all the way down, green, up arrow, space, dash S, enter, and we go look for the test case we created. Test bank account deposit with given begin balance. So it should be 150, and it is 150. So notice our constructor gave us more functionality for a class, but we didn't break our code, which is what we're always after. And that's why we're constantly accumulating that test bank, which allows us to regression test our application, right? So we should be more comfortable. What is that regression test? Like code that already existed merged with new code, and then the current test cases should not fail, right? So that's regression testing, meaning we didn't break anything, any functionality, and that's good. If you were testing your code in main, yeah, I mean, you could probably do something like this to test your changes, but as your code grows and grows, like you won't be able to do simple tests like this, right? Especially if you have classes talking to other classes, then it's kind of like, well, yeah, you can do main, but it still won't be as fast and as efficient as and acceptable as test cases, because notice here we're creating a test bank of test cases. So we will also test withdraw. So we will test this one, but with a begin balance. So we'll say, okay, so now I want to create a test case, test bank account withdraw with some given begin balance. So we have to create a bank account instance, and preferably with a begin balance of 100, and then I say account.withdraw. We'll go with $10. So our assertion should check that get balance is equal to 100 minus 10, or 90. And then we can run our test case. So run in terminal. Any questions so far? No questions? And linking. Okay, so let's scroll to the very bottom. So as long as we see green, we should be happy, right? That means that we're not breaking anything. Up arrow, space, dashes, enter. So notice our test case passes. Test bank account withdraw with a given begin balance. The given balance was 100. We made a withdrawal of $10, so our balance is 90. And notice how our bank account is working as we expect it to work. Any questions? Yeah. So we use function overloading, and this process, believe it or not, that's the name of it, constructor overloading, right? So So if one function's name is function, and then we have a function with the same return value, same name, but different parameters, then that concept is known as function overloading. And if we have two constructors with obviously the same name, but different parameters, then this concept is constructor overloading. And you can see that if we had more private data, then we would probably have multiple different constructors to initialize our data depending on the object that's used in our class. Also, in here, I'm just assuming right now that they're giving me a good value for balance, okay? But in reality, like, we should write some code to make sure that they're not giving us an invalid balance. And we will try to do that later. Like, we'll try to write some code that checks that, and if not, then it'll return an error to the user of our class. But more importantly, it won't let them create an instance with a bad begin balance, okay? Here we have control, so we initialize it to 0, but we don't have control when users of our class are creating instances with a given balance. For right now, we're just assuming that they're giving us the correct balance, right? Okay, so let me see. So we always want to make sure that we test our class thoroughly to make sure that we are not breaking anything, right? So begin balance, negative amount, that didn't change, so we should be okay. Withdraw. Okay, so if we look at our code and we think of test coverage, so what is test coverage like? What are we doing, right? Like, how many unit tests do we want to test or to create to make sure that we feel confident that we've tested our code sufficiently? So we can infer, right, that if this initializes to the correct balance and deposit works correctly and get balance works correctly when given a balance, and withdraw, then we're like, oh, okay, so we should be okay because we didn't change this code and we didn't change this code. So we are probably okay with not testing every case. However, in the real world, for this class we're okay, right? But in the real world, since this is dealing with financial data, then they would want us to create the test case for all the test cases for no constructor and all the test cases for each constructor we create, just to make sure that something weird's not going on, okay? But in this case, I'm not gonna keep on creating test cases for all, matching test cases for all the default constructor apps, object instances, okay? Hopefully you understand what I'm saying, right? So here for now, for this class, it's okay. For the real world, they'd want us to write the same test cases, creating a bank account with a starting balance, okay? But I think for now, I think you all get the point, right? That test cases will help us make sure that we're not breaking anything. Okay, so I come back here and go over here and come back to agenda. Okay, so access specifiers, class constructors, default constructor, class constructor definition eliminates. Okay, so I talked about that. Class constructor overload. Okay, so we're good. So now we will talk about delegating constructors. So if we come here and we look at this, so delegating constructor. Well, first of all, before we talk about what that is, we all know that free functions can call each other. They can, like we've done that, like when you create two functions and they may call each other. So if free functions can call each other, then functions in a class or class functions or methods can call each other. What does that mean? Well, I should be able to call get balance here. Notice it lets me, so get balance. Okay, so that, oh, actually not here, sorry. In the CPP here, I can call get balance. So we have a function that calls each other. And for constructors, we can have constructors that use each other for coding purposes or initialization purposes. However, the syntax will be a little bit different. And if we go back to bankaccount.age, we're here, and then we're like, okay. So I have the default constructor, this one. What if I want to say, well, when anybody use, even though I initialize this to 0, anytime somebody writes code like this, bank account with no parameter, this constructor will be called. But I'm like, well, anytime they do that, what I want to do is I want to call the bank account constructor with one parameter and send in the value 0. So this constructor, what does that mean? When this statement executes, there's no constructor argument. This statement will execute first. This initializer list will execute second. We will call the bank account constructor with one parameter, the value set to 0, and balance will be still 0. Not the best example, but I didn't want to add extra code, right? So my whole purpose here is this is the concept of a delegating constructor. A constructor that calls another constructor to initialize data. Questions here? Everything crystal clear? Or you don't know what to ask? I'm explaining everything well? Yes, no? Feedback? Okay, so one student says that it makes sense to him, which is good. So hopefully there's no questions, right? So if they put an initial amount, it will be 0. Okay. Yeah, mostly they're for private data, okay? So I have one question. So if they put an initial amount, will it be 0? So again, we have to understand how constructors work. There's no initial amount here or constructor argument. So when that happens, this code runs, this one right here, and then this code, which sets the balance to 0. It's already 0, but the whole purpose here is to show you that a constructor can call another constructor when you are creating a class. However, if we send in a balance, this constructor is called. So B is value of 100, and then balance gets the value of B, which is 100, and balance is overwritten. So the balance will be 100. We will not be like, I know you sent me 100, but I don't care. I'm going to set your balance to 0. No, it will stay at 100 because this constructor is executed. Okay, and that was for Leticia. Leticia was asking that question. Constructors aren't just for private data. Well, they're for initializing data. And if we are following encapsulation principles, then most of the time they're for private data. Okay, I won't say always because there might be use cases out there for other data specifiers, right? And when we get to inheritance, then you'll see what I'm talking about. Not data specifiers when we get to class inheritance. Okay. How is this better than our original default constructor? Well, this use case may not make it seem like it's better, but as your class grows, you'll see that other constructors working or constructors working together can initialize data for you, right? So as you get more constructors, you're like, hey, wait a minute, like I can use that constructor too, like to help me initialize data, and you're like, oh, okay, so let me use it. So it's like an alias, how I think of it. Okay, so I think we've covered constructors extensively, and I do it like this because constructors are actually very important, because they only help you initialize data. And let me see. Well, I'll think of a better delegating example for next time, right? As we grow our class, but for now, we'll leave it like this. As a matter of fact, for now, I will destroy this. So I go back, because honestly, that code doesn't gain us anything, which probably prompted that question by Timothy, right? And then I can say, well, I mean, if you are not doing anything, if this constructor is not doing anything, then you are behaving like the default constructor. So now here we say, hey, bank account, you are behaving like the default constructor, which in the future helps us and other developers be like, oh, okay, so that's behaving like the default constructor, meaning it doesn't do anything, okay? And then we leave this the same. Okay, so now we're good to move on. And what's the next topic? How do we use the bank account object with regular functions, with free functions? So can we pass it in as an object to a function? And the answer is yes, we can. Okay, so make sure you understand that these functions are free functions, like the one we've been studying before we got into classes. They are not part of the bank account class. So we will say here void let's display balance, and we will accept a bank account user defined type as our parameter. And then we come back over here and we're like, okay, let's write some code, and then free functions not part of the bank account class, right? So now you can't blame me if you're like, well, I thought the free functions were part of the class, right? So I'm putting it in like I'm screaming at you, right? Like they say in social media, because I'm typing in all caps. So then I do this, and then I'm like, okay, so now I create my free function code definition. I'll make this easy. So I'll come back up here. I have to include the IOStream header file. And now I can come back to bank account, and I can say cout. I'll say display balance, okay, so that we know that it's the function executing. And then we'll say account dot get balance, and then I'll say create a new line. And this code is now available for us to use. And this is actually a good example for the question we had in the quiz, where like when you use a class, you have to create an instance of it, right? So you create an instance of it. But when you want to use a function, you just use it. Display balance. I don't have to create a variable for display balance. I just use it. It's a function. And then I say, okay, account. And for now, I will see, that's fine. Okay, we should be okay here. So let's go ahead and execute this code. Examples, module 6, run in terminal. Okay, so up here, so notice right here, display balance, which means this code executed, we accepted a parameter account, it came in here, and then this statement executed, and we displayed the account's balance. And we passed it by value, by reference, or how do we pass the parameter as? The one that's highlighted right here. Anyone? By value, right? Meaning a copy is created, which means that if I try to get cute, and change the value, I will be changing the value of a copy, and we can verify that here. So these are the values we have right now. 100 when we call the function, and after the function exits, it's still 100. And we deposit 50, it's 150. Okay, what does that mean? So we create the instance, we pass a copy of account into display balance. This executes, displays the balance, and now we are trying to modify the deposit, the balance with deposit. However, we are modifying a copy, and we can show that by running the program again. So 100, the function executes, it exits, the value is still 100, meaning we modified a copy. So if we come back here, stack, so a bank account was created in the scope of main function memory, assuming we had the statement display balance here, and then we pass a as a parameter. Then display balance function would get another chunk of memory, and there would be another balance over here. And that's why the value for balance stays the same, the balance in main, because we are modifying a copy. If we change this parameter to reference, and this to reference, now we are not creating a copy. Instead, we will be working with only one balance, and we will change the value, which is not what we want, right? So we come here and we run in terminal. We never want to trust functions to do the right thing. We always want to guard against that. Okay, so notice, let me make this larger. Okay, let me scroll up. So right here, so balance 100, after the function executes, the balance is still 100. Balance 100, after the function executes with our reference parameter, notice now the value did change, and that's not good, because if it says that that function is going to display the balance, then we should enforce read only. We could use value, but the best thing to do is to use const reference, right? So now we use const reference here because this is a complex object, meaning a class object, and we don't want to create a copy of it, but we want to restrict the users to what they can do with it. And now it's telling me, hey, you cannot change it because it's read only. So now if we do this, then now we have the code we want. Yeah, you would add const, and if we run the code again, it'll run, and we will be protecting the account object from accidental changes. So come back over here. 100, after the function executes, it's still 100. We removed the statement, right? But I want to show you that our code still works. 50 to 100, 150, 150 minus 10, 140. And that's how you can work with objects in classes, in functions, sorry. One more function, we will create a function that returns a bank account object. So we'll say get account, and we will request some balance, right? So some begin balance or something, and that one can be by copy. Okay, it's an integer and we're okay. So then we come here, and now we are saying, okay, so get account. I can say, okay, bank account started with whatever balance is, and simply return account. Oops. Simply return account. And notice, so we're like, okay, create an instance of bank account with whatever the value of balance is, and then return it. We come back over here, and we're like, okay, so can I say equals get account with a value of 100, and will my code still work? Run terminal. A little bit right there. So display 100, 100, 50, 150, 10, 140. So that's how you can work with objects using functions to either consume them or create them and return an instance of them. Okay. Any questions? Could you flip back to the CPP for a bit? Yeah. Yeah, right here. This is a new code I added after line 20. Any other questions? Okay, let me see what we got left. Classes. We're good, right? So next lecture, we will take a deep dive into functions and memory. I mean, classes and memory, and objects in memory, and how they appear in memory, and what happens when we copy classes to one another. And then the following week we will get into inheritance. So we still got a lot to go, but it'll be fun. Okay, so don't leave yet. There is a